What I'm going to show you today is really what I consider a first pass, and I'll start going through what I meant by first pass. This was an idea that a colleague and I came up with as we were talking about what was going on in AI and how to keep track of it and everything. And we said, why aren't we using our own technology to help ourselves? And she ended up leaving and abandoning me. She moved to New York to be with her partner. And she was going to come and present with me, but she ended up not being able to make it. So unfortunately, with her new role. So I'm here alone. And she is much better. So I'm the CEO of Nara Logics. So I don't actually do this on a daily basis, build these connectomes, which I'll explain to you what they are. But I did in this case over the weekend, and Elsie's much better at that. So please forgive me. Everything that's wrong is my fault. Everything that's right is because the team's awesome and we have a cool product. So why arXiv? Google Scholar has come out at one point and said, 20% of the AI papers are concentrated in arXiv. And if you don't know arXiv, it's a great resource for research papers and what's happening in research papers. I'll tell you some about the growth in a little bit. But it was started a long time ago at Los Alamos. That Lannel up there is Los Alamos. Funnily, I was there at the time. I worked at Los Alamos in August of 91. The whole point was, let's share information. How do we make sure that research papers are generally available? They were all over the web at the time. And so the point was, let's get them together in one place. Luckily, Columbia University has picked up this cause and are doing a great job in keeping this together. Now, I wanted to focus specifically on AI, what was happening in AI. arXiv is, as you can tell, covers a whole bunch of different fields. So what I did was pull out some categories related to AI. I'm calling it AI-ish, and I'll go over exactly what I did to do that. But they were kind of, honestly, a little bit more interesting to me, too. So there's a bias towards that. So this is the base of the information is arXiv. They have a great API, by the way, so it's easy to pull down the information on the papers. So what is this thing I call a connectome? Well, that's what we do. So Nara Logics has a platform for ingesting data, and that's what we call our connectome builder, and for requesting information from that ingested data, and we call that our engine, our connectome engine. And why do we call it a connectome? The connectome is a wiring diagram of your neurons, primarily in your brain. But this is a mouse's retina, and the big blobs are neurons, and you can see all those little connections are how the neurons are wired together. And we're just actually, in the last few years, we're just learning how to track, how to be able to see this. And so one of our advisors, Sebastian Sung, is actually working on, he has a book out, came out a few years ago. It's called The Connectome, and it talks about how those pathways get built and what makes them fire and not fire. And so in shorthand term, your genome is your nature, your connectome is your nurture. So this is how you're building information. So that's the purpose of what we do, is to figure out how do we continue to build knowledge from data, and then how do we make that responsive to the context. So that's what I was trying to do, was building a connectome of the AI data in arXiv. What's important about that? It's kind of funny because these are headlines of papers. Some of them our CTO and co-founder wrote, and some of them are even more new research that are coming in. But basically, what's really important is that top one at the base level, and I'd say that's really what I covered in in this talk and in building this connectome is really how do you reorganize a network as you bring more information in? How do you weigh connections and make sure that things, as you learn more information, you store it correctly and appropriately as to how it relates to other information that you have. So, for example, as you come to a conference like this, you get a lot of new information. Some of that new information reinforces what you know already. Some of it you throw out because you say, wow, that's not relevant to me at all. I don't care. I don't need to remember that. And some of it you go, wow, I don't know much about that. I don't have any connections like that. And your brain starts building those connections. And to do that, to store all of that efficiently, your brain has to do this synaptic reorganization. So it has to decide, when do I strengthen a connection? When do I weaken it? When do I decide it's not important at all? And that's what that synaptic reorganization is. That's that base level. So when I say a first pass, that's the base level of what I've done with the arXiv information. The second one is really interesting. That's more about the responsiveness. So when I start learning things, when I go into a context, you all have this feeling, you know, when you read something new and you're like, that's related to something that I've been talking about. And you're making that connection. You're pulling up certain bits of information and you're connecting that to this new information. And I had this just happen. I'm reading a book, a new book, by Eva Martyr, and well, it's really about her work, and which is some of this last point here, which is about neuromodulation, and it's lessons from the lobster. And the basic point is it's showing how the muscles in the lobster's stomach respond in different circumstances. So some of it, obviously, it's responding to processed food. And then in other circumstances, when it has to flight because of fear, it's actually making its tail flip faster. And so those same muscles are acting differently under different situations. That's neuromodulation because it's done by a different chemical. Well, I was reading that and I was like, holy crap, this could solve some problems that we've been talking about with our customers. So we work with the federal government. And part of it's with the CIA, and we're trying to help analysts find more relevant information for their particular mission. Tons of information coming in from all different sources of all different credibility. Which is the information they sort through? Well, it kind of depends on what's happening, right? Context makes a difference. So that context of the lobster, whether it's eating versus running from something that's going to kill it, that's how it responds differently. And so it actually brought up a new idea that I got really excited about it. And I called our CTO and I was like, hey, listen, remember that clustering problem that we were having when we were talking about dynamic clusters? That's kind of what neuromodulation is doing in this case, don't you think? And so we actually have a new idea just based on that. But that's exactly the point is, I didn't know anything about how these neuromodulators were working, but as I read it, I could relate it to my situation. And that's the kind of thing that we're trying to do is it's kind of like dynamic clustering, but then putting an excitatory film over it, if you will. So that's kind of what we're trying to do with the arXiv thing is, how can I make sure that what I'm seeing is not just the things that other people are reading, it's more about what's important to me and what's important to my context right now. So what did I plan to do with this? And this is what Elsie and I planned to do with it. We were going to build a connectome of the data, so this basic thing that I did, of what was related to AI. And then we were going to standardize authors. You know, if you've ever looked at the arXiv data, it's not clean at all, which is true of most of the data in the world. But there's a lot of things that you can apply to it. So, you know, it's simple things like Jeff Dean is listed as Jeffrey Dean, and sometimes he has his middle initial and sometimes he doesn't. And no one's going through and standardizing that data at all because why? Would they? You know, it doesn't really benefit them. They're just trying to publish things. So I was going to pull in some databases to help standardize that of publications and conferences and stuff like that. I was going to augment affiliations. Affiliation is who you work for or who you work with. I thought that was going to be some important information in there. I was going to add a connection graph. So a lot of people are doing collaborative filtering now. That's kind of how we think of connection graphs. So it's like, I watched this movie and this movie, and you watch this movie and this movie, well, you'll probably like others that I've watched. So I wasn't going to do that on, we take a more general view of connection graphs, of that kind of collaborative filtering work. So one of the ones I was going to do was author, publication, author, so that people, if two authors are connected via publication, they can be connected directly themselves. So it's building direct links. Some people will call it inference. So it's things like that that I was going to do. I had a wish list if I was going to do some classification code weights. So what I mean by that is what's really the most important classification code for AI. So there's a whole bunch of them that are coming in, and you'll see that in just a few minutes. I'll give you some of those numbers. So I was like, well, maybe I can start putting some weights on what's important in the classification codes. And then I wanted to figure out the whys. Like really, when I bring up, and you'll see as I show you what I got to, why is this going to be important to me? That's really critical. And so I wanted to focus a lot on that. But basically, I got the first point down. So question is here. And so the first point that I did, and this is what I was referring to earlier, is all I did was I brought in four of the primary AI categories. So I did the computer science AI, I did stats, machine learning. I did, because I'm interested in that, obviously we deal with neuroscience, so I wanted to do neuro and evolutionary computing. I also worked with genetic algorithms before, so I was kind of excited to see what was going on there. And then this is quantitative biology, neurons, and cognition. So those are ones that are important to me, which is why I started there with those. And all I did was just pull every article in arXiv that had one of those as a classification term, not a primary classification term. And you'll see that in a few minutes. So the question is, why didn't I get all that stuff done? Well, besides the fact that I waited too late. Because we all do, right? Procrastination. What really slowed me down is I haven't coded in a really long time. I started out my career as a programmer, so I was there. But yeah, these new things, like I was writing the team. This was from this weekend, as you could tell, as I was getting started. And I was by a pool because it was a holiday weekend. And I was eating watermelon, drinking water, and sitting by the pool and thinking about connectomes. And I sent some questions and thoughts, and the first response back was, we have to get you set up on Python and Pandas. I'm like, oh, are you kidding me? I have to learn a language now? But it was really totally cool. So you can teach an old dog new tricks. I never had Python on my machine, and I'm so excited and jazzed about it now. I'm like, this is awesome. There are so many easy, nice tools out there today. So that's one thing, is don't be discouraged. Even though it slows you down, it's going to speed me up in the end. I know, right? You guys agree? Yeah, okay, good. I felt that way, but it was painful. I did feel like that dog, I have to say, being twisted around. The other thing that slowed me down, and this is kind of a little bit the opposite but similar of the cobbler's children have no shoes. It's kind of like the cobbler's children have demo shoes. And our systems, we have a whole bunch of our stacks. I didn't want to spin up a new stack for this of our platform. So we have a whole bunch of them sitting around. And so I just glommed onto one. Well, of course, I choose one that didn't have, the extra support on something. So it was kind of like one of those things where it's like our, things are not fully baked in demo systems, and so that kind of slowed me down too. But it was a fun exercise nonetheless. So where did I get? So it turns out there are about 30,000 papers that are in these, they're tagged with within these 4 categories. What I thought was interesting is that 90% of those, even when I just searched for anything tagged with those, 90% of those are tagged AI. So that kind of made me feel good. I was like, well, that's good. I picked a good set. That they all, even though the primary category is different from CS.ai, they all were tagged AI. So I felt like I was getting a good representation of AI in general. And that was since 1993 is about 30,000 papers. But what's interesting too is that since just in 2018, I did it this weekend, so we were 8 months in, there's been about 5,000 of those papers, so it's a lot that have been there. And in all of 2017, there were only about 5,400. So it's really rapidly increasing. What I also thought was interesting is you can see, hopefully you can tell that other bubble is bigger. So I did these all relative to the other bubble on the left from starting in 2093. That other bubble down below from 2018 is bigger. And what I liked about that is that means other categories, people are using AI more in other categories. Remember, that's the primary category. AI is just a subcategory. So what's cool is more people from other areas are pulling AI in. And I truly believe, having come from a scientific background, that's where we're going to have our biggest discoveries. It's not just about AI alone. It's about AI collaborating in other places. I did, and it surprised me, and I was sad, actually, that the neuroevolutionary algorithms actually have decreased relatively inside. I was relatively, because I was hoping that some other techniques other than just deep learning were going to come out and start doing more. And I still hear a lot about GAs, but I guess it's, again, relatively getting smaller. And qualitative biology, neuro and cognition is actually staying about the same. So I just thought it was interesting to see what's happening right now in the first 8 months of this year versus what happened since 1993. So those are the nodes. So, So we build the connectome, if you think about it. I'm talking about this wiring diagram. It's a weighted associated graph, right? So each of my nodes is connected to other nodes by a weight, and those weights are associations. And so when I'll talk about nodes a lot, and we're often talking about the proper node, like which paper am I going to recommend that we look at? And you'll see it as I show what turned out. So when I say proper node, I'm usually talking about that. But those nodes are connected to other nodes, again, by a weight. Those other nodes are of different types. So in this case, I just took primarily what arXiv had. And terms are actually categories. That's just their word for it. They call it terms. So those categories that I was talking about, the primary, and then it allows you to do secondary terms as well, categories. That's the first one. The second one is the primary category. The next one is what month it was published in. And so I just, again, went through and looked at things. I didn't even know if month published would be interesting or not. I just put it in there. Again, this is just fed in with no kind of training on the data. It's just everything is sort of weighted equally as information. What I did think was interesting, though, and the reason there's 2 graphs there, on your left-hand side, the number of nodes with each property, you can tell that most of those first things, the papers have them. That information is there, which is pretty cool. So there's terms for every paper. There's a month that it was published, of course. There's an ID. There's the primary category, authors, of course, and the primary author. But then it starts tailing off for keywords. I just pulled out keywords. I did some NLP work on the titles. And then I also did NLP work on the published So I thought it was interesting that, there's quite a bit of data in there, but then it falls off on kind of interesting data to connect it, like things like keywords. But then if you look at it, how connected, basically what's interesting here between these two things is this means that terms are really the thing in arXiv that's really reaching out and relating things, right? Because this is a lot, even though every paper has it, how many each paper has and how they're connected is actually drawing most of the wiring diagram. And the reason why I look at things like this when we're building connectomes is I want to know what's primarily going to be driving connections between papers. And that is oftentimes when we're looking at things, how do I then reach out and find more information? So that affiliation, you'll see one of the learnings that I have is getting those affiliations for people is going to be really important to me because I want to have more connections than just those categories. Categories are really, I think they're pretty coarse-grained. And so I want something that's really going to help me differentiate. The next one is primary category again, so I'm doubling down on category there. And then published month, which I just thought was funny that was coming up so often. I mean, of course, it's always published and it's always there. So there wasn't much interesting you'll see when I show you a few of the things. Keywords aren't showing up a lot. I did a couple of different models. We have about 8 within our system that you can just trade off and see which ones do more connections. I didn't find a lot and this is just title keywords, but I did it in 3 places. I did summaries, titles, and published references. So when people said it was published at this symposium or something like that. And there's lots more opportunities, again, by layering in more data. Just to give you an idea, so you do know a little bit about what's happening, I'm not trying to promote our product, although it's pretty cool. This is something that we did for one of our customers to understand what was happening with their specific data. We have a whole bunch of different modules in that connectome builder that I was talking about. So it's going in and automatically finding a lot of things. And parsing through dates and stuff like that, so you don't have to do it. This is why I literally could do this over a weekend, is because it does a lot of that stuff. What's not shown there, because they didn't have any data, this was a financial thing, so they were more dealing with a lot of the probability in ranges. It was looking at portfolios. What didn't happen in that case was a lot of NLP. So for this, I did actually quite a bit of NLP and seeing what was going on. The nice thing is I did a little bit of cleaning because there were some things that were causing it to choke a little bit. And so I did a little bit of cleaning in that case to process things. It was a lot of special character stuff. So I put in a few bugs that we need to handle, a few special characters. So when you get to some of the nodes, like I said, what came out, I mean, you've seen this already, the terms. The biggest term is CSAI, which totally makes sense, StatML. CSLG came up too. You can see the different, so terms or categories, sorry, I should have gone in and just changed that. But this goes in order, so you can kind of see like what really is bubbling up as far as these papers. You first get, and it's not that surprising, the first title keyword that comes out is neural network, which also, again, I look at some of this stuff and I'm just kind of validating, does this even make sense? Does it, when I look at the top things, the top connections that are being made, does it make any kind of sense as far as the data? And this really, it looked normal to me. I wasn't extremely surprised that there's a lot of CS that's happening. I was a little surprised that math didn't come up a little bit sooner because, I mean, AI is really just math. So I expected to see a little bit more of the math categories come in. But they didn't, and that's just what the data is. I think, again, some things around keywords and linking some of the keywords to actual math terms would actually probably help some in this case. So I just pulled up what are the most connected papers, so which ones have the most information. It's not that surprising. What happens here is, if you look at this, this is proceedings of a conference. So imagine in proceedings of a conference, there's a whole bunch of authors. So it's getting a lot of authors in there. Most of these are driven by authors. I can't remember which one it is, but there's one of those 5 that is actually driven by terms. So it was covering a whole range of topics. But again, I did not weigh in the system. I didn't put any weights in. Everything's just basically 1-to-1. And so authors are kind of easier to game because obviously there's more people than there are categories. So on the connectivity side, the least connected papers were these. I just thought that was interesting to look at too. Mostly, again, it was authors or categories that drove this. So several of these were just because they only had the CSAI category. So now let me actually show you the connectome, which is kind of cool. Oh, sorry, I forgot. You gotta go out of slideshow mode to, oops, not that. Here we go. So this is, again, our demo platform, but if you want to see things like, if I want to filter and see what was going on, let's go with what was happening at NIPS. No. Sorry, timed out while I was talking. So what was happening at NIPS? The top connected paper from NIPS is one by Hugo, which kind of doesn't surprise me if you know. You can see the, so one of the natural language processing that pulled out that pub ref right there. It pulled out also to say, hey, this was published at NIPS, which is why it's kind of getting a double down on that. From that, as well as from the journal reference. So that's going to build out its connections, which is why, again, it makes sense. I'm not saying that's the final product. Again, this is a first pass. But you can start to see when you look at this what's happening there. So, sorry, I probably should have. Another thing I could do is pull in pictures of the authors. I just realized that I didn't pull any graphics in. There's space for graphic. So you can see some of the information here. So there's the terms that I was talking about. Those categories are there. The summaries, like I said, I didn't put the NLP of the summary in because I didn't find it to have much signal then. Then it's giving me papers that are closely linked to this. So how are these connected to other things? So if I'm interested in this paper from Hugo as the primary writer, then what else might I be interested in? And it's going to tell me why this is too. So it's really closely, and remember when I talked about that synaptic network that's reorganizing? So what it's doing is it's going in and saying, wow, relative to everybody else, this is much more closely linked to stat.ml. Okay? Then it's also linked for papers published in the month of June. So that's what it's doing, is it's bringing all the information in. It's saying, wow, as far as relative to every other paper, this one actually is highly linked to this. And it's trying to give whoever's looking at this what's interesting, why they might find this interesting. Like I said, I don't think the month will be interesting in general, but it was just data that I was like, throw it at it and see. Now, what I can do is in the system just go in and say, yeah, I'll kick out month because I don't care about it. And I may care more about recent dates or something like that.
What about like citations?
Yeah, yes. I have that. I don't have it in there, but there's 2 challenges with citations. So it's in the PDF. They don't actually have it in the API. So we do have a PDF parser, but it's much more complicated to set up. And sitting by the pool eating watermelon, I didn't want to do that. So I do want to do that. That's on my wish list, and I think that's a good one for the connection graph too. People who cited this also cited that, and I want to build one of those too. So the other thing that I didn't get done, which I'm really bummed about, the team tried to get it working for me this weekend, and I just want to show you. So as I mentioned, this is just kind of discovery. I wanted to see what the data looked like as it came in. This is the really cool thing that I wanted to get done, and it's my fault that I didn't get it done. But so this is that whole demo system thing. I didn't realize that it was on another demo system until we got it all built. But this is basically a heat map, a tree map of what things are connected. And so the team they quickly shoved it into the other demo machine. And so they were trying to run some similar things that I did. But this one is, basically what they did is they wanted to see what some of the folks, Jan LeCun, Ian, Jeffrey Hinton, were saying about these different, on your left again, there are these different things. Like, what were they saying? So they just did a search for a few people and a few things. And this is the resulting kind of cluster. And the terms, again, my fault, because I didn't go in and put actual name terms down there. But you've got the CSLG, you've got StatML, you've got general adversarial, which came from the NLP, So you're starting to see how it's connecting things and what the strength of those connections are. So the bigger it is, the more purple it is, how strong that is. Now what's cool is you can actually go in, oh, this is the one that they did a refinement on. So that just kind of shows you, wow, when I do a bigger search, I can start to see how this stuff is connected. And actually, in this system that's on this other one, and this is what I want to show you guys, is you can click on one of those boxes, and basically it's going to add it to the filters on the left, and then you can do a slider to say, make this more or less important. So remember when I was talking about under different situations, it can actually make something act in a different way. Like I was talking about the stomach muscles for a lobster. That's the kind of thing that this is doing, is it's actually saying, yeah, I'm in a different situation now, and what I really want to highlight, that's not the cluster that the machine sees, but what I want to do is brighten that one thing and make sure that those weights all change, and I can see what everything looks like relative to that. So it's pretty cool. So this one was, oh yeah, he just did the NIPS thing there at first. And then he did a refinement where he said, I wanted to look more at I'm sorry, we just did this right before I came in here. So that was the NIPS one, just to show you, because I had done the NIPS search. This is the one that he did a refinement on, which is, he went in and looked for Ian as we were looking for, and GANs, because Ian's the godfather of GANs. And then he went in and made the next selection, which is he clicked on the second thing down is, okay, I want to see, I think it says, what is that, how to? Oh, using. So what he said is he wanted more papers on how do I use GANs, not just about the theory behind GANs, but how do I actually use them. So that's the difference between those two. Is the first one was just Ian and GANs, and then the next one he said no, and he saw that from the map that there was some keywords that says using GANs, and he was like, yes, that's what I want to drill into, and now I want to see the papers that are really related to that. And so that's the kind of idea here, is that you're able to go in and say, okay, highlight that, put more energy behind those connections, now see how that changes my graph. So what were my learnings, which you already brought up, and thank you for that. First is, the big thing for me that I got excited about, and I think that using GANs is a great example of that, is one man's junk is another man's treasure. And you have this happen to you all the time. A friend sends you an article and it's like, this is so cool, don't you think this is cool? And you read it and you're like, it's okay, but I'd heard about that already and it's not really an impact, and you don't understand why they're excited. Well, they're excited because, again, that lit up things for them, that made connections for them that they hadn't seen before, that they felt applied to them and what they needed. So what I really think, as we talked about this more in the office, this is something that we're going to actually start using so that we do each find our own interest in the archives paper. So one man's junk is another man's treasure. So this is about being able to personalize. But in order to personalize, and this is why the citations is one of them. You see that's the last thing there is PDF citations. So I definitely want to bring that in. I also think that there's some things like paperrater.org is doing some archive paper ratings. And I thought it'd be interesting to get that kind of people and human feedback as well. I've already mentioned the connection graphs and some of the other things that I want to do. To me, that's just kind of basic data cleanup. Like this was a rough draft. That's kind of polishing the draft and getting to a first draft. And so the first segment is really about getting to the first draft. And that's I think I'm right at time too, right? Yeah, not over time. I mean, time for you guys to ask questions is what I mean, if you have any. Sorry, that was a whirlwind. I'm not sure if this is what you were expecting when you saw a wiring diagram for arXiv, but hopefully it was a little bit of a fun foray across. How many people use arXiv? And do you think it'd be interesting to kind of see how things are connected rather than just doing searches? It's like, how is this wired to this? And I think I'm excited about that aspect for us.
Using maybe NLP to extract keywords, that's one maybe to try to understand the text and see those relationships.
Yep. Yeah, and I definitely saw things like that in both the title part and the published, what it was published in. And I think that if you then use keywords and then also match with some known entities, so doing a combination of extraction and dictionary for matching, there's going to be some really powerful things there. Cool. Yeah, I was thinking about that too. That was one of those things where I was like, oh, do you go deeper with arXiv or do you spread out? And I don't know yet. I mean, if anybody wants to, just reach out to me. I'm really easy to find. I'm Jana Eggers. I'm Jana Nara Logics. So, but reach out to me if you guys are interested in this. We were just talking about in the office. Maybe we start, letting people contribute here, like, hey, I'm willing to put the engineering paper graph in there. So if people are interested in that, we're happy to do that. We think it's, like I said, I think there's a there. So, awesome. Thank you guys. I appreciate it. Have a great day.